In this episode, we move from general security operations into the world of applications, because so much of modern business depends on software doing exactly what people expect it to do and nothing more. Brand new learners often think about cybersecurity in terms of devices, networks, or user accounts, but applications are where data is viewed, entered, processed, stored, and exchanged every day. That means applications are often one of the most direct places where security weaknesses can become real business problems. If an application handles identity, customer information, payments, medical records, internal workflows, or administrative functions, then weaknesses inside that application can create serious exposure very quickly. Assessing applications is the practice of looking for those weaknesses in a deliberate way before attackers or careless mistakes turn them into actual security events. Vulnerability scanning, static analysis, and dynamic analysis are all part of that larger effort, and each one helps reveal a different part of the security picture. Before we continue, a quick note. This audio course is part of our companion study series. The first book is a detailed study guide that explains the exam and helps you prepare for it with confidence. The second is a Kindle-only ebook with 1,000 flashcards you can use on your mobile device or Kindle for quick review. You can find both at Cyber.Me in the Bare Metal Study Guide series. When people hear the phrase assess applications, they sometimes imagine a single technical test that produces a clean answer about whether a program is safe or unsafe. Real application assessment is more thoughtful than that. An application is made of code, logic, inputs, outputs, dependencies, permissions, data handling, and connections to other systems. Weakness can appear in any of those areas, and some weaknesses are easy to spot, while others are subtle and deeply tied to how the application behaves under real conditions. That is why security teams use more than one assessment approach. Vulnerability scanning helps look for known issues and insecure conditions. Static application security testing, SAST, examines the code or code structure to find patterns that may introduce security problems. Dynamic application security testing, DAST, looks at the running application from the outside to see how it behaves when it receives requests and input. Together, these methods help teams examine both what the application is built from and how it acts when people or systems interact with it. A useful starting point for beginners is to understand why applications deserve their own kind of security attention. Applications are often the layer that connects users to sensitive business functions, which means they are close to the assets that matter most. A person may log in through an application, upload documents through an application, approve transactions through an application, or retrieve confidential records through an application. If the application does not correctly manage access, validate input, protect data, or enforce expected behavior, then all the network security in the world may not be enough to prevent misuse. Applications also change frequently. New features are added, old code is modified, libraries are updated, interfaces are expanded, and business deadlines push teams to move quickly. Each change is an opportunity for improvement, but it is also an opportunity for weakness. Assessing applications is therefore not just a one-time security ritual. It is a recurring discipline that helps organizations keep pace with the reality that software is always evolving, and evolving software always deserves renewed attention. Vulnerability scanning is often the first assessment method people encounter because it feels direct and relatively easy to understand. A scanner looks for known weaknesses, insecure settings, outdated components, exposed services, or recognizable patterns that suggest the application may be vulnerable to specific problems. This makes scanning valuable because it can help teams find issues that are already documented and widely understood in the security community. If an application relies on an outdated component with a known weakness or exposes functionality in a risky way, scanning may help surface that quickly. For a beginner, it helps to think of vulnerability scanning as a broad searchlight rather than a complete investigation. It can point toward likely concerns, but it does not always explain the deeper cause, the true exploitability, or the business impact by itself. Scanning is useful because it is efficient and repeatable, but it becomes most powerful when teams treat the results as the beginning of analysis rather than the end of analysis. One reason scanning matters so much is that known weaknesses are still a major source of real-world risk. Organizations sometimes assume attackers succeed mainly through exotic or highly original methods, but many incidents begin with issues that were already documented, already understood, and in some cases already fixable for quite some time. An application may include an old library, expose a test function that should have been disabled, rely on weak default settings, or reveal error details that help an attacker understand how the system works. Vulnerability scanning helps reduce the chance that these more recognizable issues remain hidden simply because nobody looked systematically. At the same time, beginners should understand the limit clearly. A scanner is very good at recognizing what it has been designed to look for, but it is not a human mind reasoning through every business rule or every unusual interaction. This is why strong teams do not treat scan results as the full truth. They treat them as one important view into application risk that must be combined with other forms of assessment. Static application security testing, SAST, takes a different path because it focuses on the application's code or code structure rather than its behavior as a live system receiving traffic. This kind of analysis looks for patterns in the source code, program flow, and implementation details that may create security weaknesses. A beginner can think of SAST as reading the blueprint of a building to see whether the design itself contains dangerous flaws before the building is fully used. It may reveal insecure input handling, risky function use, weak error management, poor access control logic, or other patterns that deserve correction. One of the biggest advantages of SAST is that it can help teams catch problems earlier in the development process, sometimes before the application even reaches a production environment. That earlier visibility matters because fixing a weakness while the code is still being actively developed is often easier, cheaper, and less disruptive than discovering it only after the application is already live and relied upon by real users. SAST is especially valuable because it helps developers and security teams see weakness at the level where the weakness was introduced. If a developer accidentally handles user input unsafely, exposes sensitive data through poor logic, or skips a control the application should enforce, static analysis may reveal that issue by examining the code paths involved. This can lead to deeper learning because the team is not just finding a symptom. It is often finding the implementation pattern that created the symptom. That matters for long-term improvement, since correcting the pattern can prevent the same mistake from appearing repeatedly in new features. At the same time, beginners should understand that static analysis has its own limitations. It may report issues that turn out not to be exploitable in the real application context. It may miss weaknesses that only appear when the application is running with live data, real configuration, or connected services. Like scanning, SAST is valuable, but it is only one part of a fuller assessment strategy. Dynamic application security testing, DAST, approaches the application from the outside while it is running. Instead of reading the code, DAST interacts with the live application or a test instance of it and observes how the application responds. This is useful because applications are ultimately judged by behavior. A secure-looking design on paper does not help if the real application accepts unsafe input, reveals sensitive information, fails to enforce access restrictions, or behaves unpredictably when users do something unexpected. DAST can help surface these kinds of issues by sending requests, varying inputs, and observing outputs, response patterns, and error behavior. A good beginner way to picture DAST is to imagine examining a machine by using its controls and watching what happens rather than opening the machine to study every internal part. That external perspective matters because it reflects what an attacker or ordinary user may actually experience when interacting with the application in the real world. One of the strengths of DAST is that it can reveal weaknesses that only become visible when the application is live, connected, and responding under realistic conditions. An application may appear sound in code review, but still behave unsafely because of deployment settings, environment differences, session handling, access checks, or how multiple components work together at runtime. DAST helps expose those practical issues by evaluating the running system as a system. That is extremely helpful because security failures often happen not from one isolated coding mistake, but from the way several pieces interact once the application is active. Still, DAST has limitations that beginners should understand. Because it does not directly inspect the source code, it may miss deeper internal weaknesses that do not clearly reveal themselves through visible behavior. It may also struggle to understand complex workflows or hidden logic without careful setup. Like the other methods, it works best when used as part of a broader security effort rather than as a standalone answer. A very important beginner lesson is that vulnerability scanning, SAST, and DAST do not compete with one another. They complement one another because each method sees the application from a different angle. Scanning is strong at recognizing known issues and common weaknesses that match established patterns. SAST is strong at showing insecure coding practices and problematic logic earlier in the development process. DAST is strong at revealing how the live application actually behaves when it is used, stressed, or given unexpected input. If a team relies on only one of these methods, it may gain a partial picture and miss important risk. When the methods are combined, the organization gains a more complete understanding of application security. The same issue may appear in different ways across those methods, and that overlap can strengthen confidence that the finding matters. In other cases, one method may reveal a weakness that the others would never have surfaced on their own, which is exactly why layered assessment is so valuable. Another important idea is that findings are only useful if people know how to interpret them well. A scan result, a static analysis warning, or a dynamic test finding does not automatically tell the full story of risk. Some findings are false positives, meaning they appear concerning but do not actually create exploitable exposure in that specific context. Some are lower priority because the affected feature is not reachable in a meaningful way. Others are far more serious than they first appear because they involve sensitive data, important business functions, or access to powerful actions. Good application assessment therefore requires human judgment. Teams need to ask what part of the application is affected, what data or capability is involved, how realistic exploitation would be, and what business impact could follow if the weakness were abused. For beginners, this is a crucial insight because it shows that security assessment is not just about generating findings. It is about turning those findings into sound decisions about what needs to be fixed first and why. Assessment also becomes stronger when it is tied to how applications are actually built and maintained. If security is only invited at the very end, after design choices are locked in and deadlines are close, then findings may be treated as obstacles rather than as useful input. When teams think about scanning, SAST, and DAST earlier and more consistently, security becomes part of the development rhythm instead of a last-minute surprise. That means weaknesses can be caught closer to the moment they are introduced, and fixes can be made while context is still fresh in the minds of the developers involved. It also helps development and security teams work more constructively together. Developers do not just receive a late list of complaints. They receive earlier visibility into patterns that matter and can learn from them over time. For a beginner, this matters because it shows that application security is not only about testing the finished product. It is also about creating a process where security learning is woven into how software improves from one version to the next. It is equally important to understand what these methods may miss. Vulnerability scanning may miss subtle flaws in business logic, where the application technically works as coded but still allows harmful behavior because the rules were designed poorly. SAST may identify risky code patterns without fully understanding whether real-world exploitation is possible in the deployed environment. DAST may miss deeper code-level issues or logic paths that are hard to reach through ordinary interaction. None of these methods alone can fully understand human intent, organizational context, or every possible misuse case. This is why application assessment should be seen as a disciplined effort to reduce uncertainty rather than eliminate it completely. Strong teams use these tools and techniques to improve visibility, not to create a false promise of perfect assurance. For beginners, this is actually encouraging. It means the goal is not impossible perfection. The goal is a more complete, more thoughtful understanding of where the application may fail securely, fail unsafely, or need stronger protection before users and adversaries put it to the test. Simple examples can help bring this topic into focus. Imagine an online application that accepts file uploads from users. A vulnerability scanner might identify that an outdated supporting component has a known weakness. SAST might reveal that the code handling the upload does not properly validate file type or size before processing. DAST might show that the running application accepts unexpected inputs and returns an error pattern that leaks useful information about the server. Each method reveals a different part of the risk story. Another application might have strong code hygiene in many places, yet DAST reveals that one user can reach a function meant only for administrators because the live access control behavior is weak. In a different case, SAST might uncover that a sensitive token is handled unsafely in code, even though DAST and scanning never clearly surfaced the problem. These examples show why layered assessment matters. Applications are complex, and meaningful security understanding usually comes from examining them through more than one lens. Another practical lesson is that application assessment should not stop once a finding is fixed. Fixes need validation, and teams need to confirm that corrections actually solve the problem without creating a new one. A rushed fix can sometimes close the visible symptom while leaving the deeper cause in place. In other cases, the fix may introduce a different weakness or break part of the expected workflow. Reassessment helps reduce that risk by showing whether the application is stronger after the change. Over time, this creates a cycle of improvement. The organization assesses the application, interprets the results, prioritizes the work, fixes the issues, validates the improvements, and then continues assessing as the application changes. That cycle is important because applications rarely stand still. New features, new integrations, new user demands, and new dependencies all create fresh opportunities for weakness to appear. A beginner should therefore see assessment not as a checkpoint that happens once, but as an ongoing conversation between security, development, and the evolving software itself. As we close, the main lesson is that assessing applications requires more than one viewpoint because software risk appears in different forms depending on where and how you look. Vulnerability scanning helps identify known weaknesses and insecure conditions that deserve attention. SAST helps teams inspect the code and find risky implementation patterns before or during development. DAST helps evaluate the running application as real users and attackers might experience it. Together, these methods create a much stronger picture than any one of them could create alone. For a brand new learner, this topic is important because applications are where business value and security risk often meet directly. When organizations assess applications thoughtfully, interpret findings carefully, and keep the process tied to real development and real behavior, they are far more likely to catch meaningful problems early and far less likely to leave important weaknesses waiting in plain sight for someone else to discover first.
Thanks for listening. For more audio courses, daily newsletters, and more, please visit DailyCyber.News.